In this lesson, we are going to learn how to apply the concepts we have learned to solve examination questions. For every question, I will encourage you to pause the video and try it out first before proceeding to listen to my explanation. Let's begin with this question from GCE O Level Pure Physics examination in the year 2011. A car driver takes a total of 2 hours to make a journey of 75 kilometers. During the journey, she takes a break of half an hour and spends a quarter of an hour stationary in a traffic jam. At what average speed must she travel during the rest of the time for the whole journey to take 2 hours? Note that in this case, the question is not asking for the average speed for the whole journey of 2 hours. It is asking for the average speed for the rest of the time when the driver is driving. In the quiz question that you did, the question asked for the average speed for the whole journey. So the total time was from 11 a.m. to 12 noon, that is 1 hour. Whereas in this question, it specifically asked for the average speed for the rest of the time. The rest of the time means taking 2 hours minus the half hour that she took a break and minus the quarter hour that she was at the traffic jam, which equals to 1.25 hours. Hence, the average speed is computed by taking the total distance of 75 kilometers divided by the rest of the time, that is 1.25 hours. The answer is 60 kilometers per hour. Now, when you solve examination questions, remember that once you have understood a concept, you already have the ability to solve any questions by applying the right concept. What is important is to be careful to read the question correctly so that you apply the concept correctly. Next, we look at a question from Cambridge O Level in year 2021. A boy starts at P and walks 3 meters due north from P to Q, and then 4 meters due east from Q to R. What is the shortest distance that he must now walk to have an overall displacement of 0? For his displacement to be 0, he has to be back to point P. Hence, the shortest distance must be along the path 5 meters. Next, we look at a question that has come out a number of times in past year's examination. The diagram shows a strip of paper tape that has been pulled under a vibrating arm by an object moving at constant speed. The arm was vibrating regularly, making 50 dots per second. What was the speed of the object? This question does look difficult. When you solve a question, start by writing down all the parameters that you are given. You are told that the vibrating arms make 50 dots per second. This means the time between each dot is 1 second divided by 50 dots. Next, you are told that this is a length of 20 centimeters. And if you count it, there are 10 dots. That means the distance between dots is 20 centimeters divided by 10, which is equals to 2 centimeters. The answer options are in centimeters, so you can maintain the distance in centimeters. The next step is to write out the formula of what you want to find, which in this case is speed. Now you can see very clearly you have the distance and time taken. Substituting the data, you will get the speed to be 100 centimeters per second. The answer is C. So you see, examination questions may appear to be difficult, but if you were to write down what information you have been provided and the formula of what you want to find, you will have a very clear visualization of how to solve the question. But be careful with units. Let's look at a similar question. A student pulls a piece of tape through a ticker timer. Every 0.02 seconds, the timer prints a dot on the tape. First, the tape is pulled quickly, then slowly, then quickly again. Which piece of tape does the student obtain? This is quite a common sense question, but sometimes in exam, we might be nervous and cannot think clearly, so we can make use of formulas to guide us. We know that the formula is speed equals to distance divided by time. Rearranging, distance is equals to speed times time. So when the tape is pulled quickly, it means the speed increases, and hence the distance must increase. If the speed decreases, the distance will reduce. Therefore, the answer must be B. Finally, let's look at a question from paper 2 of Cambridge O Level. Figure 1.1 shows a cricket ball as it comes into contact with a cricket bat. The cricket ball has a mass of 0.16 kilogram and it hits the bat with a speed of 25 meters per second. After being in contact with the bat for 0.0013 seconds, the ball rebounds with a speed of 22 meters per second in the direction exactly opposite to its original direction. In part A of the question, you are required to state the difference between speed and velocity. If you answer that velocity is a vector with both magnitude and direction, while speed is scalar, it has only magnitude but no direction, you will get your 1 mark. You can also add that velocity equals to displacement divided by time taken, while speed is equals to distance traveled divided by time taken. We are required to calculate the change in velocity. Take note that there is a change in direction, so we have to set one direction to be negative. So if the initial velocity of the ball is 25 meters per second, and if we set this direction to be positive, then the other direction must be negative. Hence, the change in velocity, that is final velocity minus initial velocity, will be equals to minus 22 meters per second minus 25 meters per second. And the answer is minus 47 meters per second. With this, we have concluded this module where we learn the key concepts in kinematics. I will encourage you to attempt as many past year's exam questions as possible. When you discover that you are able to solve these questions, you will know that you are well prepared for the examination.